Hello, welcome to the talk of Alex, CUSA55. It's a very special pleasure for me because I think he's the guy who made the longest distance to the Congress. I think it's like 16,100 kilometers. He's from Sydney, and it's his first talk ever. So in case he gets a bit nervous or what, and of course, like the whole web security community is looking on you at the moment. So don't be shy. Yeah, I hope you have some fun with his talk. Welcome, CUSA55.
Well, hello, I'm CUSA55. I'll be presenting on unusual web bugs. So, who am I? I'm Alex. I'm starting uni next year. I'm working for a company called Sift who are paying a tiny bit of this, so they've got using their slides. Anyway, this talk is not an introduction to web app security, since I think we've all seen enough of those everywhere. Not about URIs or DNS rebinding, since that's been overdone. Kaminsky's talked about it, everyone's talked about it. It's a talk about new ideas and some cool and obscure things that I think most people won't know. And after editing, it's turned out to be more like unusual XSS bugs, so if that's not interesting to you, sorry. But there's still some other stuff which should be. Also, some of the stuff here was reliant on some functionality from Flash, which pretty much all got fixed a couple of weeks ago in the latest update, so that might not work if you download the latest plugin. Anyway, there's a bunch of different things I want to talk about: exploiting log data XSS vulnerabilities, protected XSS, XSS via HTTP headers, file uploads, other things which I'm sure you can all read. Anyway, if you've ever seen a talk about XSS, you've probably come across something where they've shown some bank login page where they can XSS it and they send out phishing emails, etc., etc., etc. Really boring attack because you're sending out phishing emails. Right? But you do encounter scenarios like this in real applications where the events only actually fire when the user's logged out. So what can you actually do with such an issue, since you have no credentials in terms of cookies to steal, and you can't execute actions either? So one thing which came out about a year ago but still isn't that widely known is that, for example, Firefox fills in passwords automatically. Whenever you go to a page, if you have them saved in the password manager, they'll get filled in. So simple enough, you create a form on your XSS page with the same input names, Firefox will fill it in. And essentially you have the user's passwords no matter whether they're logged in or not. Now, there is a sign-in.preforms configuration thing in Firefox, which you can change so that it doesn't fill them in automatically. However, if you know the username, you can still put the username in the first field, focus on it, then focus on the password field, and Firefox will fill that in anyway, and then you can get the password. IE does something pretty similar to Firefox with the configuration option changed, in that if you type in the username, go to the next field, it fills it in. However, unlike Firefox, it does an additional check where that form has to be on the same page as the password was saved from. So what you have to do is load the login form in an iframe, then put the username into the field, focus on it, focus on the password field, and in about like a millisecond, password will be filled in. Of course, this does have the caveat that you do need to know the username, so it generally doesn't work for widespread attacks, but if you're trying to target a specific user who you know, this will definitely work. Another thing that's been out for years and years and years, but most people don't seem to know about, is an attack called session fixation. You see, most applications give you a session when you first visit the site, not when you log in. So if you can set the cookie for a victim, then they log in. So you set the cookie to a value you know, then the user logs in with that cookie. They'll be logged in with a token you know, so you don't need to steal it anymore. So when the user's logged out, you execute a piece of XSS, which sets their cookie to predictable value. You leave it. At some point in the future, you also set that cookie to last forever rather than just a session cookie. So at some point in the future, when the user logs in with to that site, they'll be using your cookie, and then you'll have the session token and you can log in as them. Yeah, most fixes for this attack occur by actually stopping the attacker being able to set the session token in the URL. However, when we actually have XSS and they're just logged out, this is a viable attack method. So, in PHP, there's an interesting array called the request array. It actually gets used an awful lot in applications, surprisingly, because you don't actually know where the input's coming from. This array is created on the variables or directive, which first puts the environment variables in there, then the data which you get from get, data you get from post, data you get from cookie, data you get from session. This is interesting because if we have an XSS which works through get or post, but it's actually using the request parameter, we can put our XSS inside a cookie, save it to the user's browser, and then every time they come to a page, it'll fire. One other thing with XSS when we're logged out, what we can do, there are a lot of client-side things which implicitly trust the client-side stores because an attacker can't effectively edit them unless they have XSS, because it's all done by the server. So, if we have XSS, we can edit them. You see like the window location equals like a function which gets a redirection cookie. You get XSS if you pass it a JavaScript URL, and similar things. So. Now, some new ideas. One thing which, if you've read any web security books, usually they tell you for some reason or another that you need to stop the browser from caching web pages because some silly thing like an attacker might have access to a computer, it might be public, something that's not a real attack vector really. So, but one attack vector which I haven't seen anywhere so far is that in Internet Explorer it doesn't actually do any real cache checking when, it doesn't what IE lets you do is read pages that don't have cache control or expires headers set. So essentially, if, say, credit card details or personal information are sent to the user on some page with no caching information sent to the browser, in Internet Explorer, if you have XSS there, you can read those things right out of the cache even when the user's logged out. The most interesting thing, though, is really what does it mean for the user to be actually logged in? Not like the meaning of life. When you're logged in, you send a cookie tied to a valid session. Nothing more than that. So when is the user logged out? When either the cookie is invalid or it doesn't exist, malformed, etc. So can we log the user out for a single request to have our XSS vulnerability executed, but to actually still have the credentials there? Yes, we can. Two ways. First of all, Flash has an interesting piece of functionality called the add request header, which I'll talk about later, which lets you set pretty much almost arbitrary headers to HTTP requests, which also then get rendered by the browser. So, all we simply need to do, send an additional cookie header. Most frameworks, ASP, PHP, append all the cookies together, application gets a mangled cookie, and effectively, for the sake of the application, the user's logged out for that single request that we've mangled. So, mangle request, the application thinks the user's logged out, our script executes, but they're still logged in there. And then from that point onward, we can steal cookies, make requests, do anything we want to because the user's still actually logged in. Also, we can, there are some firewalls, things which may strip cookies. For example, request rodeo. It's a Firefox extension which is meant to stop CSRF attacks, but here the way it does that is by stripping cookies. Nice extension, but in this case it introduces a new issue because we can get the cookies stripped and logged out XSS attacks become workable. So. Another interesting case, which is usually considered unexploitable, is when we have an XSS issue where we can access ourselves because we obviously have a login, but it's CSRF protected. So we can't force the user to make the request because we don't know the CSRF token which is tied to their session. But what do these CSRF tokens actually do? They force you to send a token tied to a valid session tied to your cookie. Nowhere does it say that you actually need to be tied to the victim's cookie. So what we do, we simply force the victim to send our cookie, our nonce, and our XSS payload. So how do we do this? Well, first of all, we need to actually log the user out. Since we can't, with Flash or any other technology, simply overwrite the cookie, so we have to log them out, either by CSRFing the logout button or logout link and hoping that it actually clears the cookie, or just simply waiting for the cookie to expire and the user to be logged out called naturally, or stop cookies being sent with something like request rodeo. Now, next step is to log the user in yourself. First step, you can do that with Flash. Sadly, this doesn't work in Internet Explorer because there's between the actual Flash plugin and Internet Explorer, the interface to Internet Explorer doesn't let you send cookie headers, so even if Flash allowed us to send cookie headers, which it did until recently, we weren't able to. And then, if that's not available, we can do like a session fixation style attack where you put the session identifier in the URL. This way, we have the user using our session, and we can use our nonce. But this is really quite complicated. It depends on a lot of things, and really is a bit fiddly and doesn't work sometimes, especially now that Flash has patched things. It becomes much harder to exploit. One case, which is somewhat similar to this, is when we have a persistent XSS issue, but which is only rendered to a single user. For example, the user fills in their name and address or something, which is rendered back to them, and it's an XSS vulnerable field. And the form which actually does this is CSRF protected, which we see fairly often when we tell people, look, you need to CSRF protect this, otherwise an attacker will be able to force the user to have these details edited. So what we essentially do is we XSS ourselves, we have a persistent XSS vulnerability rendering on our account, and we simply log the user in with our account, and it's running in their browser, and we can do all the things I described before with logged out XSS vulnerabilities, such as abusing the password manager, raiding the cache, doing session fixation style attacks. Also, another somewhat similar case where it's not quite CSRF protection, but when we have captchas protecting forms. In some cases, we have just an image.php or image.asp or whatever, which renders the image and does all the checks. If this is the case and there's no nonce in the URL, what we can actually do is have this captcha rendered on our page. Once we have that, the user will probably fill it in since there's no reason not to. And once we have this token sent to us, we can send it right back to them and have it sent along with our XSS. Admittedly, yes, this does require some bit of social engineering to force the user to fill it in, but generally, most of the web stuff XSS does require some aspect of it, and this doesn't seem like a phenomenal leap. All right. When we have an XSS issue, half the problem is finding the actual vulnerability itself, but the other half, which this talk's mainly focused on, is actually getting the user to send the data to actually have the XSS execute for the user's context, rather than to be able to just XSS ourselves. So, how do we do this? We use Flash. Sadly, Flash doesn't let you send all the headers you'd want. It blocks things like referrer headers, user agent headers, obviously the host header, things like that. There is a general case of where we can actually still send headers though. Flash actually did some filtering really badly, and in the name of the header you want to spoof, it doesn't do the check. It does a simple check for, say, referrer, case insensitively, and if it matches, then it won't let you do it. But if you have part of your header payload inside the header name, then it will get sent through. Admittedly, this does have some caveats because you have another colon and a space appended at the end of your header, which doesn't let you do some things. For example, spoofing host headers still doesn't work because Apache IIS, etc., don't respond to those headers properly. And again, cookie is allowed by Flash, but filtered by IE. But even when this was fixed, there was another thing we could do. With the CGI 1.1 spec, which a lot of languages follow, when you access headers, you don't access them by their direct name. For example, the user -agent header is usually accessed as the HTTP_user_agent header. So, what happens when we send them a user_agent header? Well, we get a collision. In most of those languages, PHP, Perl, Cold Fusion, that collision will result in the user_agent header being appended to the value that the language accesses. Sadly, not on ASP though. So we could send user agent headers even though they were explicitly filtered by Flash. Right. File uploads are generally very hard to do right. And the issues fall generally into two categories: the actual file names themselves and the actual content of the files. There are things which pretty much everyone knows. We have dangerous file extensions we don't want people uploading, like PHP, ASP, etc. You don't want them uploading HTML files, don't want them to upload class files there, you don't want them to upload config files, etc. Don't want them to upload null bytes either because file systems aren't binary safe, so things get truncated. Most people know this. What most people don't know is that when Apache actually decides what extension am I going to use, it actually doesn't use just the last extension. If the last extension isn't mapped in the const/mime types or in one of the other Apache config files, then it'll go to the second last extension, trying to figure out what the hell do I do with this. So, if we upload a file.php.xyz file, it's going to get treated as a .php file by Apache, and again, we have code execution. Yeah. Also, one thing which developers generally tend to do, which is rather silly, but they treat the file names as trusted somehow, and they echo them into plenty of different contexts without considering, is this actually user input or not? So, we have things with a valid extension, which when echoed in whatever context, for example, inside SQL, inside HTML, are generally quite dangerous, but still trusted. Of course, on Windows, it's a bit harder because we can't use some characters as opposed to Unix systems where we can use pretty much everything other than null bytes. So, one interesting content-based attack is in Internet Explorer, there's an internal function called find MIME from data. What this does is MIME sniffing. Because back in the old days, like a couple of 5 years ago or something, when web pages were developed, most people developing were pretty much amateurs, so they didn't know that they need to get content types right and similar things. So what did Microsoft decide to do? They decided that they need to figure out what the hell is this file I'm getting served by themselves instead of actually listening to the server. So what this meant for us is we could upload image files which have HTML in them. They'd get sent back to the browser with the appropriate content type of for example, a JPEG or a PNG, but Internet Explorer would decide, no, this isn't an image, this is a HTML file, and would render it as such. So we'd get XSS through image uploads. Now, these days, GIF, JPEG, and PNG images, the first few bytes are checked against a bunch of signatures, so you can't actually do it for image files. Well, not this way anyway, but we can still do it against .txt, .pdf, those type of files. So how does it actually work? What it does is it has a bunch of hard-coded checks, which checks the first 256 bytes for these tags. So if it finds them, it says, look, HTML, I'm going to render this page. So what kind of solutions have people implemented? Well, first of all, vBulletin has tried filtering strings. They screwed up, obviously, because they didn't know the full list of strings. They checked only the first 200 bytes. But if you know exactly what it's doing, it pretty much works in this scenario. However, we don't know whether this is the full list of tags. Microsoft won't tell us because they don't want people doing this. And there are other reasons not to as well. Recommended solution is to use content disposition attachment header, which pretty much works, and so far no one's found a workaround to this. However, if they did decide to do filtering, there's a header in HTTP called the range header, which allows us to have resumable downloads. This lets us get stuff from a specific point in the file. Now, we can't meaningfully alter the range header with Flash, since first of all it's blocked because this is an issue, and the colon space at the end when we try to use a technique where we shove it into the name of the header doesn't work because Apache just won't accept this as input. However, there's an equivalent header in Apache. These beautiful 3 lines of source code which tell us if there's no range header, let's use the request range header instead, which is back from Netscape days pretty much, from the first spec for this, and so no one seems to know about it. So, what does this mean for us? This means we can get things sent to us completely out of context. For example, previously, only worked on static files in the 1.3 branch, but in the 2.0 and 2.3 branches, this is set up as a filter, so it works on dynamically constructed files as well. So, in our find mine from data example, we have IE checking the first 256 bytes, software like vBulletin checking the first 256 bytes. If we send a request range header for, say, the 257th byte and onwards, IE still checks the first 256 bytes it gets, but those 256 bytes have not been checked by the application software, and so it doesn't have the image signatures, etc. And so IE again decides, hey, this is HTML, I'm going to render it. Also, since this can be used on dynamic files, if we have issues which aren't really XSS since we can't get things executed, but because we have things being echoed in a context where they're not dangerous, for example, inside an attribute with quotes stripped or encoded, or inside a plain text tag or something where we can't close plain text, etc. Similar contexts where we have things which would be dangerous in other contexts. We send a request range header for just our dangerous string. It gets rendered in the original, in like a body context, and it gets executed. Now, on a completely different note, in PHP, there's this really odd feature, well, not odd, it probably makes sense from a performance perspective, but when you look at code, you don't see that when you're comparing a string to an integer and considering that PHP gets all its input as strings from the user, the string is actually converted to an integer. The way this conversion works is it gets all the first digits from the string, discards everything afterwards. If there are no digits, it's just 0. So what this means is if a user value is compared to an integer, and then the value itself is used rather than a hard-coded integer, then we can shove pretty much anything we want after that, causing XSS, SQL injection, command injection, whatever. Another interesting thing of PHP is it has a directive called the ignore user abort directive, which is set to off by default. What this directive does is tells PHP whether we want to ignore the user closing the TCP connection to the server. So since it's off, we can theoretically stop the execution of the PHP script at any time. Usually this isn't much of an issue because state really isn't kept between most scripts. However, if we have a script which uses multiple calls to write to a persistent data store, such as a database, we can induce a potentially unexpected state. For example, if we have a banking application which doesn't use transactions in SQL and uses 2 separate database calls, one to transfer money from one account, the other transfer the money wherever, one to increment a value, one to decrement a value, we can stop it halfway between it. Problem is, we're doing this remotely. Timing attacks are horrible remotely. So we really need a way to draw things out. We can't really do this with the file system since it works fairly well with a lot of load. However, databases don't, especially on shared hosting and things, really don't work well with high load. And they start taking seconds or more to respond to a single database call, especially if you have an intensive page, such as a search, being hit lots and lots of times. So if we do this, we get about a second between database calls, and that's more than enough time for us to kill the TCP connection. PHP script stops getting executed, and we have a malformed state in the application. A lot of applications these days are moving towards internationalization, and so we're getting a lot of support for different encodings. Thing is, most developers still have no idea about them. So in MySQL, for MySQL, for example, there are a bunch of different escaping functions to use. For example, in PHP, the MySQL real escape string function is used. It is itself encoding aware. However, first of all, it needs to be configured to know what encoding you're using in configuration files. And secondly, it's possible to use a query, an SQL query, which changes the character set of your connection, but doesn't change the character set of your escaping function. So then, in effect, it turns out to be not encoding aware. And some, like add slashes and magic quotes, just aren't encoding aware to begin with. So, why is this an issue? Well, because if we have a query like the first one up there, where we have our input, and we're using encoding unaware functions such as add slashes, which is the easiest case, if we shove in a quote there, it'll just get escaped with a slash. What we can do, if we put in an incomplete multi-byte character just before our quote, such that the multi-byte character formed with our byte and then the backslash form a valid multi-byte character, in that case, it'll be just considered as text, not as any kind of escape. And so when it gets to our multi-byte character, which is a byte and a backslash, it's just text. But when it gets to our double quote, which was originally escaped, it actually thinks this is the end of the thing, and we're back outside of quotes, and we have SQL injection. Second method for this would be if, for example, we have two inputs, and we have a character which we can create where the second byte is a double quote, and we'd get SQL injection through this kind of encoding attack. So, does this actually work? Well, for the first method, yes. After writing a fuzzer to check MySQL, I found that these four character sets, those hex codes there are the first byte of a multi-byte character, which has, those are the first byte, backslash is the second byte. So you shove them in there just before your first quote, and it's as if they were never escaped. Second method, there are no multi-byte characters which exist where a double quote or a single quote or any other quote limiter is available multi-byte character. So, who the hell would actually do something like this? Well, phpMyAdmin for one, which is fairly well used and uses the exact MySQL query, which is set character set to some user-defined value. There are also a lot of less well-known software which exists, but they're less well-known. So not awfully much really, but that's pretty much because we only use UTF-8 in most of our applications. We don't need any support for exotic character sets, so this might drastically change in international applications. So, moving to browsers. Like the second SQL injection attack method, if we have two inputs, one inside an HTML tag attribute, one outside, probably two different escaping functions are going to be applied to them. For the one in the attribute, the most common thing to do is simply encode quotes, therefore you can't jump out of things. Yep. Obviously, this was an issue due to the range headers, but another issue here is that the input there, okay. Since the only thing that the escaping function does for the first input, which is inside a HTML attribute, is to remove, to encode quotes, if we have a multi-byte character where the first byte is something we control and the second byte is a double quote or a single quote, then we have our second piece of input still actually inside the HTML tag. And so if we simply put an event handler or a style thing, we can execute JavaScript because we're in a different context than what it's filtering for. And that URL, which you can see, there's a list of vulnerable char sets, so there are a lot of them. Not so widely used, but yeah. Browser encoding is really odd, actually. When we have, at the top you can see, those two href attributes are pretty much equivalent for the browser. When it accesses it, first thing it does is decode the HTML entities so it can use them. But this doesn't only happen for href, source, etc. attributes. It happens for event handlers as well. So down the bottom, where the quotes are HTML entities escaped and not escaped, they work identically in the browser. So what does this mean for us? This means that those two pieces of HTML there are functionally equivalent in the browser. So the first one would be what happened if we just had func and then our data inside, and it was escaped with something like HTML entities. Our quote would be encoded, but when the browser got it, it had just decoded itself, and we'd have pretty much the equivalent of the second one. So HTML entities inside event handlers doesn't do anything at all, even though it's touted to be pretty much the solution to all our XSS problems. Now, something which rarely gets fixed is admin-only SQL injection, because we consider, oh, why would the admin want to do SQL injection against their own application? They already have this kind of access. So the thing that's generally not considered is, wait, can we force an administrator to do this? And we can usually, if they're not CSRF protected. Problem is, if we have the CSRF issue, SQL injection issue in the same place, it's completely blind. It's blinder than normal blind SQL injection because you don't even know if it errored out or not. Well, almost. The things that do leak, pretty much timing information, since you know when your iframe started loading and finished loading. So if we put in some code there which, for example, ran MD5 like 1 million times or something, there'd be a noticeable time difference between that and when the exploit failed. But also, most developers generally consider at least part of the database data which they're extracting is trusted. They've pretty much put it there. Why would they want to filter it again? So, since we have SQL injection here, we can control what data is given back to the application. Since it's trusted, it's not escaped, and it's outputted unencoded, we have XSS there. With XSS, we can essentially see anything that happens on the domain. So we've got vision now, it's no longer blind at all. This would be pretty difficult to exploit, except for the fact that I can't pronounce the name, released a tool a while ago which allows us to proxy requests over XSS. So essentially this tool is a SOX proxy which you can either connect your browser or some SQL injection tool to, and then simply proxy everything over the user, over the administrative user and into the application. Now, again on the topic of CSRF, if you ever have gone to the MSDN website, you'll see that Microsoft calls CSRF a one-click attack. Makes no sense to me, but we can actually create a real one-click attack where we can hijack user clicks. With CSS, we have a lot of powerful features such as CSS overlays, which allow us to put any part of the page on top of any other part of the page. We can also make those parts invisible. But when we make them invisible, they're still there, so you can still interact with those elements. So what we can do is load an iframe to the very front of the page, make it invisible, so when the user clicks on something they think is on our page, they're actually clicking on something inside an iframe on a different site. So when is this actually useful for us? Well, advertising, Google AdSense or something, you only need to hijack a single click and the user's gone to the advertising site. Or for example, sites like Dig, where we have, you only need one click to get something dug. Or the case where we have XSS issues, which are usually considered fairly impossible to exploit since you need the user to click on an actual link or something to actually fire, we can simply load an invisible iframe. They think they're clicking on a button on our page, but they really click on an XSS attack on another domain. Now, one of the things that I find really odd is that we end up talking a lot about the same origin policy, but that's not the weakest link in browsers. The weakest link in browsers is actually the cookie policy. Unlike the same origin policy, cookies are actually shared across different ports. So a cookie which works for port 80 will work for port 81, port 8080, etc. So if you have a vhost aware Apache server and you're serving a bunch of different websites from there, and you have something which isn't vhost aware, like even like an echo server or something which just sends data back or an FTP server, if you go to a vhost and visit the different port, your cookies will get sent to the other application. Furthermore, cookies, unlike the same origin policy, aren't even restricted to the single domain. You can have as you can see, you can have cookies proceeding with a dot in them. They're shared with all the subdomains below them. But not only that, we can set cookies for domains above us and below us, from JavaScript even. So what this means is if we have an XSS issue on, say, a subdomain or a different port, that'll also, and in those scenarios, it might be completely useless. For example, you might have some exceptionally trivial applications without accounts or something, so XSS there isn't usually an issue. However, by abusing the cookie policy, we can either try to steal cookies from over ports, or try to set cookies and conduct session fixation attacks across subdomains. Now this becomes really interesting when we consider the fact that XSS doesn't actually have to be over web servers. We can do this over non-web servers. If we have protocols such as IMAP or IRC or whatever, just echoing data back unencoded, we can send commands to them. How do we do this? We create a form with an enctype of multi-part form data, set the method to post, and what happens then is our post data is not actually URL encoded as it usually is, but it can be split up onto different lines. So if we create a form like that, put in a text area tag, put in our payload, use JavaScript to submit it to an application, and these applications, since they're plain text, they usually expect users to actually type the commands out themselves, and so dodgy lines such as all our HTTP requests are usually ignored as just, oh, the users typed some crap in again. And they also generally tend to send things back unencoded, because first of all, any kind of encoding would break a terminal, and why would they need to encode things? It's not as if there's a web client talking to them. Sadly though, this doesn't work in the 2.x branch of Firefox, nor the 3.x branch. However, it does work in Internet Explorer. So, one of the things which with XSS is a real issue. With SQL injection, if we don't want to be found out, it's pretty easy for us to just use a proxy somewhere else and send our data over a bunch of different proxies to make it almost impossible to trace to us. However, when we're conducting an XSS attack, even though the IP address and cookie information, etc., are all coming from the user, the XSS still needs to contain the information for where we want to send information to. For example, if we're stealing cookies, we need a server which is going to log them. If we're conducting actions to say, like, move money from one bank account to the other, we need to know that other account. So we need to use some kind of technique to make sure that the server doesn't get this information, but the client does. So first of all, the first way the server knows who it is the referrer. The referrer can be stripped with meta tags and meta refreshes, or faked with flash. So that's pretty much easy to fix. However, the fact that we need to send the XSS to the server and to actually get it echoed back is usually a big problem, except for the fact there are some channels which we can send to the client, but which the client doesn't decide to send to the server. For example, URL fragments. Everything after the hash on that page, if you type it into a browser, won't be sent to the browser, but any client-side script can still access it. So we could easily create a piece of JavaScript which simply got the cookies, got a host name from the URL fragment, and sent all the cookies to there. Or we could put an account number there, or whatever. Another interesting client-side channel is the window.name JavaScript property. This is populated usually via JavaScript when you're doing pop-ups and things, but it's also populated when you have an iframe tag and you specifically set the name attribute to whatever you want. You can set, like I said, a place to drop cookies, an account number to transfer money to, whatever you want. You can even include your whole JavaScript payload in there and just have, for example, eval name, that's it. That could be all you send to the server. And since I've talked really fast, that's it. Any questions?
One question regarding your aspect of PHP.
Which one?
You
Sorry.
presented that there was this eGPS arrangement of variables. This can be shut off by just avoiding register globals.
Sorry,
Really?
which one, sorry?
Sorry?
Could you state the question again? I didn't quite.
Well, it's actually a comment. This PHP vulnerabilities in your talk. Well, PHP has, sadly, yes, an unfortunate history of vulnerabilities included, but well, I think it can be avoided just by making sure it's avoiding register globals.
Well, no, the typecasting issue is there no matter what configuration setting, and the other one has nothing to do with register globals at all. It does rely on another directive, you're right, which can be turned off. Back here somewhere. Gone too far. Yeah, this one. That can be gotten rid of by setting that directive to on, but, or am I missing something?
No, yes.
No? Right.
You're right. You just presented some new ideas for me, what can be attacked, and I hope I did take care in the past. Thank you.
Thanks.
With your attributes and these entities in attributes, why isn't it sufficient to just escape all HTML special characters? Because in your example, if you run, for example, the PHP function HTML special chars, then the Amsterdam would be converted to Amsterdam AMP, semicolon. So that would prevent the attack. But here you say encoding input in event handlers doesn't help much. Why not?
Why? Because when you send it just the double quote, it gets converted to the quote thing, right? But the browser converts it back to the actual double quote before executing it. So if you send it the one down below, if you send it that second one, if you send it test, double quote, close parentheses, semicolon, etc., it'll get converted to what's up top. But when the browser actually decides to use it, it'll be using what's down the bottom. So can I?
Okay, yes. Now I understand what you mean. Okay, thanks.
I have to disagree on this because it would be double encoded.
No, but you send it the double quotes. HTML entities converts it to end quote. The browser converts it back to the double quotes, and then it executes it.
Well, at first I got what you have on the first line, right?
No, that's not what you send it. You send it everything from the test to these double forward slashes. You send it that. When you use HTML entities, what you'll get as a result is what's up top, right? But when the browser decides to execute it, it'll convert it back to this second one, and it'll get executed that way.
Okay, now I understand. Thank you.
No, sure.
Hey, great, excellent talk. One of the most information-dense things I've seen in a while. I was wondering how many protocols you've seen that actually echo back input from the web browser. So you mentioned IMAP. How many others have you seen?
SMTP does, if depending on the authentication. I haven't really played with that too much, but all of the ones I've seen do echo